We are here for another episode of This Week in Science. I hope that's what you are here for as well. It's time. Time for another week. Time for some more science. How are those microphones? How's that internet?
Checkity check.
Check 1, 2.
Check.
Check.
3, 4.
Somebody send me a check. Okay. That would be very nice. All right, let's make this happen. Y'all ready for this? Boom, chick, 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 chick it. We're going to do this show starting. Wait, no. There. Ha-ha. There we go. Now we're going to do this show that we know and love as This Week in Science. Remember, this is the live podcast broadcast. Things may get edited for the end podcast. If you are watching this now, that means that, hey, you got the live, unedited, warts and all version. And welcome. We're so glad you're here. Let's begin it in a 3, 2. This is TWIS. This Week in Science, episode number 903, recorded on Wednesday, November 30th, 2022. Does this wormhole go to Science Town? I'm Dr. Kiki, and I certainly hope it does. Tonight we will fill your head with cannabis, cocaine, and death metal. But first...
What? Is that our show? Really?
Yep.
Disclaimer, disclaimer, disclaimer. The following program has been carefully designed to make you think. We have chosen subjects, topics, and stories pulled from the current week of scientific publication. This content considered challenging and dangerous to beliefs. If you subscribe to any of the many thousands of common false beliefs, you may find that science regularly refutes things you thought to be true. This is not intentional, but cannot be avoided because God, the Illuminati, aliens, and Bigfoot all got together and planned it that way. That doesn't mean that flat earthers can't hang around, though the flat mooners should really leave now. Seriously, even the astrology crowd don't believe you, and they all think that space is flat. Creationists continue to claim that not even... and the old arguments they consistently put forward show that to be somewhat true. The racists, the conspiracy theorists, the misogynistic enthusiasts all base their ideas on false facts and uncritical thinking. Still, extreme caution is advised for anyone maintaining such thoughts, especially those that can be easily refuted by facts, as those beliefs are considered highly combustible and should not be placed in close proximity to children with matches or questions. And definitely such ideas safely hidden away from the open flame of critical inquiry that is This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back to talk about, well, the past week in science. It's This Week in Science,
True.
What was published. Yes, what did we find enjoyable? Yes, yes. Let's get into it. It was a nice last week. I hope there were many people taking time, and thanks, and lots of gratitude and everything. But, we're back. Time for business again. I have stories about holographic wormholes, cannabis contradictions, wolf pack parasites, and octopus nervous systems, as well as dun 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 bird jaws.
Good one.
It's not Shark Week. It's Bird Jaw Week. Justin, what'd you bring?
I have brought how we can save the planet from global warming,
Awesome.
cocaine biotech, the emperor who never was, or was he? And new space minerals never before found on Earth.
Woohoo! Do the minerals wear any clothes like the emperor? Okay, Blair, what's in the animal corner?
Oh, I have the previously discussed death metal and also some poop.
Sounds like a fantastic combination.
This is a science show.
Yeah.
Okay,
Yes.
I'm just checking. Just needed to.
Yeah. If you search the word poop on TWIS.org, you will find we talk about it often.
Quite a bit.
Because
quite a bit.
poop
Everybody.
science is important science. It
Yes.
really is.
And in this case, a little hint, it is goose poop science. So there you go.
Ooh. So I don't think we've had goose poop science on the show before. So this.
Yeah.
Oh, lots of birdies. Okay, let us dive in to this wonderful world of science. Yes, it might not sound like it could be science with all of these descriptions, but that's what it is. We're talking about science tonight, as we do every week. And if you are not yet subscribed to the show, I implore you to head to your favorite podcast outlet, platform, etc., and look for This Week in Science, otherwise known as TWIS. We are on YouTube, Facebook, and Twitch every Wednesday night, live streaming at 8 p.m. Pacific time on Wednesdays. And we are TWIS Science on Twitch, Twitter, and Instagram. If all this is just too much, go to twis.org. That's our website where you can find us and lots of other information. Okay. Are you ready to dive into the one-dimensional quantum wormhole?
Are you talking about the new Ant-Man movie?
No, I'm talking
Oh.
about science, like this.
Oh, got it. Okay.
This week's
Kang will not be arriving. Got it.
No.
Continue.
no. Kang will not be arriving yet, but we might be working on a way to make that happen. Researchers publishing in Nature this week, out of a variety of different organizations. It's the California Institute of Technology using Google's quantum computer, Sycamore, which is in Santa Barbara, California, near the California Institute of Technology. They've created a quantum entanglement gravity experiment on a chip in which they have created a one-dimensional holographic wormhole.
Huh?
Wormhole. Like
But-
wormholes, like
Where's
Einstein-Rosen
it come
bridges.
out the other side, though?
It can't. It's only one dimensional. There's no another side. There's not even a side.
There's this this experiment takes sides.
I know. It opens up at that black hole that they made in a lab that you talked about a couple weeks ago, right?
So this is kind of like right. That's right. A couple of weeks ago they were doing the black holes. They
Yeah.
started glowing and emitting the little. It's like, woo, that's happening in a lab. This is totally different. Different researchers, but wormholes. Yeah. So okay, physics in labs. It's small scale, but it's getting it's getting wild and crazy here, people. Researchers have been trying to study the idea of the holographic universe and looking at the ideas that have been put forward by numerous physicists over a very, very, very long couple of decades, several decades. Initially, researchers, Einstein, Rosen, others have posited the idea that there are these places where physics breaks down, classical physics breaks down, and you lose relativity, and there is a quantum space where things kind of take over and particles go, what am I even? And that's inside of a singularity, a black hole, and that inside these black holes, there could be points that connect other points in space, single-dimensional points. However, in the current view of our physical space, which is understood, if you want to look up this idea of de Sitter space, De Sitter space is the idea that our universe has no end. It's infinite. It's expanding. It's not sitting still. It is growing. Anyway, researchers were like, hey, that doesn't quite work. And then Gerard de Hooft and several others were like, oh, look at this idea of anti-de Sitter space. And this is the idea of a finite universe with a very finite surface from which information, bits, zeros and ones, could then be projected into the space inside of it. That's a holographic universe. Not like holograms from Star Wars. Not like, help me, Obi-Wan Kenobi, you're my only hope. No, this is a two-dimensional surface full of information projecting into a three-dimensional, four-dimensional space-time. That's anti-de Sitter space. That's not our universe. Our universe is de Sitter space. So, okay. Whew. Anyway.
Wait, is it?
Yes. Our universe.
Okay.
So now, these researchers are like, okay, we want to understand gravity. We like this idea of like, oh, the anti-de Sitter space, because we might be able to play with variables a bit. This anti-de Sitter space is just like different because it's just like anti. It's like antimatter. It's a negative value instead of positive values. It's finite instead of infinite. And it's a physical spherical cow, which physicists can go, oh, look, we can study physics now. And so they're using quantum computers to do it. Enter Google's massive quantum computer and these researchers who decided to say, oh, look, we can take these sets of entangled particles and we can, like we know we've talked about entanglement on the show before, where you have a particle A that's over here and a particle B that's over someplace else. And when particle A goes whoop-de-woo, particle B goes whoop-de-woo at the same time. And if you change the way that particle goes whoop-de-woo, then the other particle changes in a very similar manner. So entanglement, we know this is a thing. We know this happens. And so these researchers were like, oh, let's take sets of entangled particles. So they had 7 qubits that were entangled together. And they were like, oh, look, all 7 of them go whoop-de-woo at the same time. And their entangled bits on the other side go whoop-de-woo on the other side at the same time. Look, they're entangled. That's awesome. Okay. And then they were like, let's put a weirdo 8th qubit on one side of this setup. And so the 8th qubit goes in on the left side, and then they shove it at the other set of entangled qubits with what they call a negative energy pulse. But it's basically like they're like, here, qubit, go be in here. And the qubit goes into this already arranged, entangled set of stuff, and that arranged, entangled set of stuff goes, whoa, this is different, and they change. And so that change happens, and then the qubit goes boonk and gets shot through to the other set of entangled stuff, pops out the other side, the entangled stuff, they're all doing their entangled thing. And what they found in this quantum setup, it's not a real wormhole, it's a holographic wormhole, but it's little tiny one-dimensional little spaghetti string. It's like they were like, shoot, I'm shooting peas at the other side. They found this property that they didn't expect whatsoever, which is kind of like the weird chaotification. Like if you crack an egg in real time, it cracks, it breaks, it goes bloop, you have an egg. You can scramble it, it's all chaotic, right? But it's as if that weird 8th qubit got shoved in there. It went into one side of the wormhole, kind of got scrambled, and then went, I'm not going to be scrambled anymore, and unscrambled itself on the way out the other side. Which is a hypothesized aspect of how wormholes work.
Is this like the Is this like the machine in Willy Wonka with that's like the TV, right? That scrambles the little boy up, and then he travels above everyone's head and then unscrambles on the other side of the room. That's basically what you're talking about.
That is exactly what I'm talking about, except quantum particles and qubits. Yes.
Okay, got it. I understand it perfectly now. Thank you so much.
Well, yeah, it's also the teleporter from Star Trek.
Yes,
It
yes,
is-
of course it is that too. You're right.
It is a bit. And so this is the the really fascinating part. So this is hypothetical. It's working based on this anti-de Sitter space, which is not how our universe works. It's existing in a quantum computer on these superconducting computer chips. This is data that goes in one side, comes out another side. And so researchers are like, all right, this is really great. I'm glad you did this. It's not a real wormhole, even though physics suggests that wormholes should exist in our de Sitter space universe. This still isn't giving us what we need. But what it suggests is that they have actually started to see gravity, like not just, oh, hey, gravity, but the force that is gravity in this synthetic situation that they've created, but not in our, it's a spherical cow. It's still not this universe. There's a lot of questions that still need to be answered. It's still very basic in how it's working, but it worked. And so, yeah. Wormhole.
Huh.
It's very tiny. One-dimensional, tiny little thing working in like 2D space. We exist in a 4-dimensional universe of space-time, and there's a whole bunch of other factors that are probably involved, but this is fascinating.
Wow.
Yeah. So, will quantum computers lead us to have transporters, wormholes, or other kind of philosophical questions? If in the real world, this kind of like movement of one state to another entangled state happens, like, is this what's happening in every single moment as we move from place to place? Is it this, are we a bunch of little tiny wormholes? I don't know. This is me, not, I've had too much caffeine today.
Or does this
But
help
anyway.
explain dark matter?
does it? Right. Is it in that realm? I mean,
Because I feel
At
like
this
in a
point-
lot of ways, our understanding of dark matter is still like, this is the part of the equation that doesn't make sense, so we're going to call this dark matter.
yeah.
So maybe it's in this other dimension or universe or
Yeah. So this is kind of like,
whatever.
yeah, it's like a parallel universe, this weird quantum experiment that happened. But the ideas that they're working on and how they're working on them are certain to lead us to other places.
The thing I'm having a hard time reconciling in my brain is this a simulation or is this a physical electron that has moved somewhere? Like, what is, or what moved exactly with this quantum particle, or is it a simulated particle? Because there's at some point, then I'm like, is this a model, or is this something that was actually data that moved when you're calling it data that moved?
It's kind of a mix of the two of them.
I don't know.
Because it is a model, but you're actually dealing with magnetic forces and electrical charges in the process of creating, doing the experiment and creating the data.
Yeah.
So, and when it comes down to it, like what we're talking about is zeros and ones. We're talking about information spread.
Well, if it's a quantum computer, it's not even just zeros and ones. So that's the thing. It's like, then it's like, well, if your data is the experiment and it's on a computer and it's a quantum computer at that, then there's some point when I can't tell the difference between this is just a program we wrote.
The answer
and
is
this
42.
is a physical thing that just happened in the universe that's amazing. Like, it's starting to get to that crossroads of like, I don't know if you just like if this is you just invented Pong on a quantum computer, or
Oh
you
yeah,
unlocked the mystery of the universe. Like I can't
quantum pong.
tell.
I love it.
Quantum Pong.
Yeah, wormhole pong. Yeah. I mean, I think that is a big question, and that is that's where the research still has to lead us, and so. There are more questions than there are answers at this point in time. And I love the New York Times headline for this article, which is something about physicists create the first crappiest wormhole or something, so or not crap.
The thing I do find very fascinating,
wormhole.
though,
Yeah.
because you mentioned that they gave some sort of an insight into how gravity works, I guess. And that's sort of exciting because the thing that we have to do to figure out what gravity is really limit anything's ability to move or travel anywhere and see how it moves. See how it moves through a finite area of space, because that's down at that level of things moving in spaces where gravity is eventually going to be unlocked. And it's something that we still haven't truly understood or seen properly. So it's pretty interesting. It is.
Yeah.
I want to find out if
that's like the big plus to studying this anti-de Sitter space, because it's a finite universe. They can control variables. But ours is not, as far as we know, a holographic universe, because it's a big fuzzy edge to be projecting all this stuff in here. So
I don't know. I think Susskind, isn't he?
He's a big part of this. Yeah. And I
Yeah,
highly recommend.
I would follow whatever Susskind says.
He's publishing on this
with.
stuff. Yes, he's publishing on this stuff. He is involved in this research, so he is a big part of this. And we're going to link to an article from Quanta magazine, which they have created a wonderful video that's about 20 minutes long that explains a lot of this. And so if you want to spend about 20 minutes digging in, we'll link to that in our show notes so that you can dive into the wormhole a little bit more.
In the same way that 100 years later, Einstein is still being proven to be correct over and over again, I have a feeling Susskind is going to be the same, have the same longevity of his ideas. I think we're going to be discovering.
Yeah, I think so.
We're going to be referring back to Susskind. For the rest of this century in terms of, oh gosh, he actually had things figured out. Oh, it turns out we are a hologram. Oh.
Yeah. One of the interesting side notes brought up in the Quanta magazine article is that Einstein and Rosen were actually working on like black holes and the idea of the singularity and all this stuff separately from the quantum ideas. And they never put the two together. They just did not think about like quantum stuff happening in the black. And so it's very interesting that, it takes decades for.
Yeah, and then when
together.
it did get brought up, then they discovered entangled particles and were like, it can't be right.
Yeah, exactly. They discovered the entangled particles and did not put it together with black holes, which I think that is very interesting. But
and also like tried to dismiss it, like, that means it can't be right. Yeah, we're brilliant. We came up with this. Can't possibly be true.
Okay, tell us how we're going to save the Earth now. Now that we have wormholes.
Oh, yeah, because we're going to need to do that if we want to be around long enough to see how these ideas pan out. In case you haven't noticed, there's a lot of carbon in the atmosphere and not a lot that's being done about it, other than we're experiencing global warming is what we're doing about it so far. World governments have pledged to plant trees to help offset carbons that they produce. They have committed to providing land for the purpose of planting those trees. At least the land. By one study's estimate, governments have collectively promised land that, when added up, would be 30% larger than the continent of Europe, or 30%-ish larger than the entire territory of the United States. When spread out across the world, though, not just, putting it all in one landmass, and you'd have to leave out, of course, the places where there's already forests, deserts, high mountaintops, other places trees don't grow. The plan would require using 50% of existing farmland to meet those commitments, which would immediately lead to global famine, not to mention the necessity of finding an arborist or a local plant store of some sort that had 2 trillion tree seedlings ready to plant, just lying around. I got 2 trillion trees here. Nobody came looking for them before, but now. So what's a world to do? Turns out there's a place where we could grow the forests we need without the downside of mass starvation. Where can we put the forests? The ocean. According to an international research team led by Michael Huchella of the Department of Energy's Pacific Northwest National Laboratory, we could begin seeding the oceans with engineered fertilizer particles near ocean plankton. The goal would be to feed phytoplankton, these microscopic plants that are a very big part of the ocean's ecosystem. We could feed them, encourage them to grow, and by growing, they would naturally take up carbon dioxide. This analysis is in the journal Nature Nanotechnology. This is quoting Hochella. The idea is to augment existing processes. Humans have fertilized. We can fertilize the oceans responsibly. And
Justin, isn't fertilizing the ocean what causes red tide and algal blooms?
Yeah. So
Right.
the way we do it right now is rather unintentional. I guess in a sense. It's just runoff, right? So we put a lot of fertilizer on land. Normally, the ocean gets its fertilizer from land and water runoff. We're adding a tremendous amount of fertilizer to the land, and now the runoff is encouraging explosions of growth off the coasts. Absolutely right. So what this would do is take that same principle, but intentionally place it in places where phytoplankton can better use it. And so what they would do is they take it up, and then when they are done, it drops to the bottom basically as a carbon sink where it can be removed and out of the atmosphere, sequestered, if you will, for thousands of years. So it's a natural process phytoplankton already do. Researchers say we could just speed it up. Their analysis, they looked at 123 published studies that showed that numerous non-toxic metal oxygen materials could safely enhance plankton growth, stability, earth abundance of these minerals, the ease of creation of the materials. They looked at all this stuff. They also did some feasibility study in terms of price-wise. At the price part, they realized that they could just use sort of raw materials that would be less efficient, a little bit more expensive to make the engineered version that was specific, but that would be significantly more effective. Because this is different ocean areas would need different sort of formulations to be most effective. So there's a little bit of knowing the waters that you're putting it into. Sometimes it needs to be more iron rich. Some places it could be more silicon would be required. But after all, they kind of, the point is time is not on our side. So at some point when we're talking about drastic actions, this might be it. This is a natural process already. Hey, more phytoplankton in the ocean. I'm sure that, there's a lot of what fish are left out there. I probably enjoy that. And we've overpromised the land. The governments are using offsets to get to a goal that they're writing checks that their planet can't cash already. So
this bothers me.
It bothers you? How so?
Do go on.
Reason that I would like to see some proof of concept that this is not going to completely ruin ocean food webs that are already stretched to their breaking point by things like climate change.
I mean, I think that's the thing that that Justin was like briefly stated. The researchers had said that if we could locally target specific solutions that
Right.
are, specific to the needs of particular areas, then perhaps we could keep from creating red tides, toxic algal blooms, too much phytoplankton, anoxic dead zones. But that is, that's the rub, right? Do we have that information? Are we really capable of controlling our input into such a big open system like the ocean and knowing what's going to come out? I mean, we've tried biological control in Australia and that hasn't gone very well.
Yeah.
So, yeah.
That's what I'm saying is we're under
Yeah.
the assumption that the artificially boosted in growth phytoplankton in the ocean is not going to impact the food web in a negative way. First of all, by maybe there just being too much phytoplankton.
Yeah.
Or it being suddenly
So-
extremely carbon-rich phytoplankton because it's absorbing so much carbon dioxide. How's that going to impact the food web?
Yeah. So here's my sort of brief rebuttal to that. We're already impacting all of those
True.
things.
Exactly. We've
severely.
already done it.
True.
Yep.
So the idea
True, but
that we
that's
don't
kind
want
of
to
my
mess
point.
with nature is a great
No,
one,
that's
and
not
I
what I'm saying at
100%
all.
agree with you. But it's
That's not what I'm saying.
too late.
Though.
Let's
I'm
not
saying
make it
we've
worse.
already messed with it so much. That's what I'm saying. Is that it has been messed with to the degree that marine ecosystems are hanging by a thread.
Can we
So
fix it?
trying to drastically change the balance within a food web in an already stressed system kind of scares me. That's all I'm saying.
Yeah, and you
I
should be
think-
scared. You should be
Yeah.
scared.
Yep.
But I don't know. It sounds like more fish food to me. So I think that would probably be all right.
Right, but then do you get more fish of certain species that then mess up the food web in another way because there's too many of one kind of fish that eats phytoplankton?
Well, then you have to
Oh,
have the
no,
really
babe.
big marketing campaign to get everyone to eat that fish instead of things like salmon and other ecologically important fish. And then you're like, great, oh, eat the ugly fish that are over. Okay, they're not jellyfish. You really do want to eat them. Good marketing campaigns
But
are
the fish
here.
right now, are moving.
Yeah, they are.
So they're already
over.
like the whole like we don't want to impact the biome. The biome is going away. The biome and its population is moving. It's changing already. So this is an effort that could that if when you're talking about fixing global warming, you're talking about at least maintain those biomes. So otherwise, the fish are going to move. They're heading to colder waters, or they're going down further to get more oxygen because the acidification, like the whole
Or they're
ocean
dead.
is all at risk.
Oh,
Yeah.
boy.
Yeah, it's the case of, have we, if we don't try something to make it better, is it going to be worse? Or do we just
And you can make the
Hands
argument
off.
on land too, like
Yeah.
growing all those
Both.
trees. Putting 2 trillion trees somewhere is going to be a major impact as well on land. This just gives us, 70-something% of the planet is covered by water. It gives us an option to tackle. And you're not talking about doing the whole ocean. It's a big ocean, But
It's all connected, though, is the thing.
so is it on land too. It's connected everywhere. Yeah, I agree. And right now, that connection is global warming.
that connection is people? And since we're talking about
that's right.
people right now, let's talk
Yeah.
about some close relatives. Blair.
Yes. You know how sometimes you look like your relatives, and sometimes the resemblance is closer than other times, whether you want to admit it or not. Just visually, you can kind of go like, "Is that your brother or is that your mom?" Because you kind of
Right.
look, you catch
Oh,
the
you've
nose,
got your
or the
mother's
chin.
eyes.
Yeah, exactly. Yeah. And so a study from University of St. Andrews wanted to see if the same was true for chimps. They wanted to see if wild chimpanzees looked like their family members, and if there were particular ways that relationships were easier to detect, like at particular ages or particular relationships, like mother-daughter or father-son or father-daughter, or any of these things. And so what they did is they set up an online game that people could play as part of a community science effort to crowdsource a data set. Turns out people really liked playing a game where they got to pick out pictures of chimps and decide who was related to who. Over 5,000 people participated. They tried their skills at matching photos of 180 wild chimps. They had to try to spot the mother, father, or half siblings. And this is all because, of course, you can't ask a chimpanzee if they recognize each other. So instead, they were trying to use this data set and humans to see if they could make a relationship guess as a human, because surely if we could do it, then the chimps could do it. And so they were trying to see if, based on kind of looking similar and humans being able to recognize those similarities, if that was an advertising of relatedness, if chimpanzees were benefiting by looking like their relatives. So this is looking at kind of a different side of the coin. So the first is just like, you look like your relatives because you're related to them. End of story. You have the same genes, therefore they express in the same way, and that's why you look the same. Seems like the obvious reason. However, is there an evolutionary benefit to looking like your relatives? And therefore, do certain unique characteristics get expressed more to identify familial relationships among us, among chimps, among other animals? They found that humans can detect family relationships in chimps at around 30% accuracy. Not great.
That's worse than chance. Like significantly
Yeah.
worse than chance.
But if you hang on though, if I'm looking at the screen here, I've got one chimp that I'm assuming is the one you got to find the relative for up top, and then 4 to choose from below. So it's better than chance. If chance would say that 25% would just be the chance. So it's a little better than chance.
But what's interesting is what you do then with data that doesn't look good is you try to identify specific subsets to see if there's specific subsets that humans are really good at recognizing. And that is that once chimpanzees start to get older, it's actually a lot easier to tell relatives in kind of the adult phases. Adult chimpanzee family pairs were easy to recognize. And in that case, it might be really helpful because this is a huge leap, I am recognizing that, it might help them prevent inbreeding. You look like my relative, I am not going to breed with you. A few families in particular in the study shared a lot of distinctive characteristics that made them easy to spot. So they're the very specific familial lines that were really well defined according to us. Again, this is all according to us. And they also found that male chimpanzees were harder to match to their parents or siblings when they were young, but parents and children, especially fathers to children. So once those boy chimps became fathers, they were adults, they were easy to match to their children.
Got it. Okay.
Yes. So they posit, the researchers suggest that this is because very easy to tell who your mother is. She gives birth and she raises the baby. But fathers often don't show a lot of direct connection when the babies are very young in chimp society. So paternity is harder to define and is more uncertain. So also showing paternity as a baby might be risky because there might be more infanticide. If you're not mine, I'm going to get rid of you so I can have more of mine. This is very common, right, in the animal kingdom. So if you can hide that to survive to adulthood, that would be great. And then once you're older, it's better for young males to be able to form alliances and, again, to prevent inbreeding. So this is all to say that's what we figured out by looking at them. But does that top chimp baby know what he looks like? And therefore, can he recognize who looks like him? Because they don't have mirrors. So how does that
would you know?
kind of leap happen? Yeah. So is there something that helps them to piece together, you look like my relative? And of course, all of that would not be a conscious decision. It would be kind of a signal that causes a response that isn't like, you look like my cousin. I'm not going to breed with you. Or you look like my son. I'm going to help you out.
I would like to see this experiment done with chimpanzees.
Yes.
I mean, we know that we can train chimpanzees to use computers, touch screens, do eye tracking experiments. Would it be possible to train them to, you get a little Cheerio when you identify your mom. You get a Fruit Loop when you identify your brother, your cousin, etc. Right? This is, you start with family groups and then you train them on the basic chimpanzees they know, and then spread it out further. I think this need to really understand if this is how they're thinking. It needs to be a chimpanzee experiment.
Yeah. No,
But
absolutely. You're totally right.
And as Fada's bringing up, pheromones, scent, there are so many other signals, sound of voice. It's
mannerisms.
It's very interesting. I think it's very interesting. But like you said, where are the mirrors? How do they know?
Yes.
So
how indeed. So I think it's an interesting example of citizen science. I think it is very cool to see how the appearance of chimps is inherited, and how you can see very clear family lines in certain groups. But beyond that, I find it very hard to draw any conclusions, and more research is needed.
more research. We love it. Always more research. But yeah, when did we start to do that? When did we get mirrors, and when did that become important? How we look as opposed to how we smell or sound.
Well, so I think part of that didn't require a mirror.
No, because we were in small tribes. Chimpanzees also work around in small tribes, and
chimpanzees do this too. But you don't need a mirror. What you need is a friend. You need a friend to come and pluck the twigs out of your hair. It's like, oh, hang on a second before you go leave the cave today, Justin. You still got sticks in your hair. You gotta pull those out. Whatever it is, we groomed each other. So I don't know. I think looks have probably been important longer than people could possibly imagine. There's all sorts of decoration and adornment going on throughout, even pre-current modern human society in humans.
And I'm sure those friends are also acting as the really good chimpanzee wingman to help you not give in to the chimpanzee beer goggles. But anyway, let's move on to cannabis. So, from
no cannabis goggles, right?
No cannabis goggles. One of the things that we have talked about a lot on the show related to cannabis is the potential for cannabis and cannabinoid compounds to be used, cannabis-derived compounds to be used to treat pain. And it would be wonderful to be able to use something other than opioids, something other than NSAIDs, things that actually that are causing lots of physical and psychological and mortality issues around the world. So people have been looking at cannabis and cannabis-derived products, and a new study was just published in the Journal of the American Medical Association, JAMA. They looked at the results of randomized controlled trials in which cannabis was compared with a placebo for the treatment of clinical pain. They were only able to look at about 20 studies that involved about 1,500 people altogether because of the way that they limited their studies, specifically trying to look for specific endpoints like change in pain intensity, before treatment, after treatment, the use of control groups, randomization, and full random control. They did find that the majority of the study's participants were female, between the ages of 33 and 62, and pretty much it was all Western countries that were involved. The cannabinoid products were administered a whole bunch of different ways, but their meta-analysis determined and actually corroborated another meta-analysis from 2021 that found that the cannabis compounds are really not any better than placebo. So they also, in this study, and this is the really interesting aspect of it, they looked at the way these studies were covered by the media and academic journals, and then tried to correlate it, obviously, to the therapeutic effects that participants reported. And they were able to show that there are a lot of examples of relationships between treatment expectations and placebo responses. In their article that they've written up about their work in the conversation, they say, we cannot say with 100% certainty that media coverage is responsible for the high placebo response observed in our review, but given placebos were shown to be just as good as cannabis for managing pain, our results show just how important it is to think about the placebo effect and how it can be influenced by external factors. Like the media. Hello, yes, us. So
Not us, though. We follow data.
Totally. Yeah, but I think it's, yeah, go ahead, Justin.
Well, okay. So, I don't know. Has it really been pushed forward as a pain relief alternative to some
CBD,
extent? But
yeah.
Is it?
Yeah.
I've never
Yeah.
heard of CBD as a pain relief. I've never.
Oh yeah,
I've heard of
there's CBD
as,
ointment for arthritis. There's CBD
gosh.
ointment for joint pain.
So,
There are
one of the things,
tinctures,
and
there's
this
all
might be
sorts of
why
stuff,
they
yeah.
had to limit their study, or not why they decided to necessarily, but why that is because the CBD has been shown to reduce anxiety. Now, that crossroads of pain isolated by itself, do you still feel this discomfort, and associated anxiety or constant thinking of that pain, if those two things have been separated, then yeah, I could see you could do that with a lot of things, though, if you're very narrowly limiting. But yeah, I've never personally thought of CBD as a pain relief medicine.
It's a big
I know
part
some
of
people
the
who
market.
have.
Yeah.
I
It's
know
a big
people
part of the
who,
market, yeah.
But I know people who have this is, and again, this is anecdotal. I know people who swear by it for this reason. But it occurs to me that if you're just being able to lower your anxiety around that pain, then you may still feel the pain. But if you don't have the associated anxiety, that's a huge relief. So
Yeah.
who knows?
I think that's an interesting point, is the difference between pain relief and just being able to forget that you have pain. Those are very different
Keep
things.
your mind off of it. Yeah.
Yeah, because
Or
a
to
friend of
not just-
mine had an experience with marijuana and pain relief, and it does not relieve pain, but it sure made it tolerable in the moment,
And so,
There you go.
this gets at the psychological aspect of pain. We talk about different people having higher or lower pain tolerances. Some of this is genetic. A lot of it is experiential, and a lot of it is related to things like anxiety, fear, and other negative emotions that can exacerbate whatever those painful feelings are. So there is something to be said for that psychological aspect. And then second, I want to say also, placebo, if it is working in some extent, if the placebo is as good as an NSAID, if the placebo is doing some amount of work to reduce your pain, it's working. to some degree. So
So-
this is the debate about placebos, right? It's not necessarily a drug or a medication, but it's working. So
Yeah, and if it's not hurting you, if it's not
it's not-
hurting your liver,
yes.
if you're
it's
not
not
spending your
dangerous.
life savings on it,
Yes.
then maybe it's not so bad.
Haha, life savings like insulin. Anyway.
Yeah.
So here's another interesting thing though. Opioids. People who have used opioids for chronic pain, and this is how a lot of how the opioid epidemic happened, is because there was strengths of opioids that were only supposed to be prescribed for short-term pain relief that were being started to be prescribed long-term. And my understanding is that the pain is still there. It's not like the opioid
You
also
just don't care
takes
about
away
it.
the pain. You just don't. Yeah. It's just you're able to completely keep your mind off it, and it might be you can call it a lower intensity. But I was watching something about the NFL. The NFL players, a lot of them had a lot of problems with opioids because the NFL American football players break their bodies during this sport, and so
Not just their brains.
And it was some guy who was a professional athlete probably 5 years ago that now uses crutches to go up and down stairs, and talking about how the pain is always there, and the opioids didn't take it away; they just made it tolerable, I think Blair was saying. So
and there have been studies. I remember Justin reporting a while back on a study in which cannabinoids were actually being used by psychiatrists as a way to transfer people off of opioids. So, and they were being used successfully. So there are potentially benefits, but whether or not they actually work for pain relief, stopping pain, getting rid of pain, that is the evidence is not in its favor. But like we've talked about, placebo, psychology, there are other potentially very positive aspects.
And I want to tag one more thing on, which is that sometimes you have a physician that tells you to take a pain reliever, not just to relieve pain. Sometimes it's a pain reliever that's an anti-inflammatory. Sometimes it's a pain reliever that's a blood thinner. And so it's important to know
how it's being used.
Why you're being prescribed that stuff. So if you decide, no, I'm going to do this cannabis rub instead, that can be dangerous if your pain reliever is resolving another issue at the same time.
Yeah.
But if it works, do it. Right? Even if it's a placebo.
Not a doctor.
Even if
not
it's a
doctors,
placebo effect.
Just discussing.
If you're talking about pain relief, if you're doing something that turns out that somebody's saying is a placebo, but it's been working for you, don't listen to them.
It'll make
Keep
you go
going.
As long as it's not
Because
dangerous
placebos,
for you.
that's the problem. That's the problem with placebos in research is that
That's not what I'm saying.
they sometimes work.
Right, that's what I said earlier. And I'm not saying that. I'm just saying we should be talking to our doctors and we should be doing things like Blair said that are not hurting us, as long as it's good. Okay, let's talk about cocaine now.
Oh, great. That's not a placebo.
Wow, that's it. Well, look at that gateway. Look at that gateway story right there.
I know, I timed it. I did it perfectly.
Published in the Journal of the American Chemical Society, a team of researchers at the Chinese Academy of Sciences, working with a colleague from the UK, have developed a way to synthesize cocaine using a tobacco plant. So we're going to hit all of the things people shouldn't be doing. Scientists have long been looking for a way to produce cocaine in a lab. They're like, oh, if we could just do that, we can quit this lab job tomorrow. Researchers have now figured out the biochemistry of the plant and have synthesized small amounts of cocaine by genetically engineering a type of tobacco plant to produce it in its leaves. which is kind of, I guess, a benefit. You've got one plant that's apparently pretty labor intensive and grows in a certain climate. Now you can grow in a completely different climate, and you can have the fields of Virginia filled with coca plants. Well, maybe not. So they got a very little amount, not enough to use this for an industrial purposes. But it is a proof of concept that they could find another way of producing. And in studying this, though, they discovered that the cocaine that winds up in the leaves is not produced by chemical elements in the plant converting compounds that had been thought. They found that it is instead produced by just 2 enzymes. So it's 2 enzymes with some additional assistance from a substance that's also produced in the plants called ornithine, which is similar to the precursor in the coca plant. Researchers note that their efforts were focused on synthesizing cocaine to produce it for use in medical applications, such as pain control, which is sort of interesting because we got all the lidocaine, novocaine, all the other
canes.
But my understanding is those were all synthetic.
From cocaine.
Already. Yeah. No. I thought they weren't derived. I thought they were synthesized separately. But maybe I'm wrong.
Oh, but so cocaine was discovered, but then all these others, not cocaine, biosimilars, like these other chemical, biosimilar compounds, were developed for the research.
They say here, also notably, the process they use to produce the cocaine in tobacco plants is far too technical for use by criminals determined to produce the drug illegally. That statement right there is ridiculous. That is the most ridiculous. Like, they would have to have a lab somewhere, and they have the money to put into some research equipment. There's no way they could pull that off, those criminals. Yeah, right. The team also notes that the amount of cocaine
I'm just shouting out to all of the DIY biology hackers that are out there, with your vertical farms and your genetics labs. Maybe you too can create your own painkillers.
So here's the thing. They're talking about, they didn't get a large amount produced from the plant. So there's like, more research. We gotta, see what else we can do. Why do you skip the plant? You have you have 2 enzymes and a precursor. Skip the plant altogether, or maybe just use it for precursor, because now you can get yeast or bacillus or something to produce these enzymes. You can put those in a bioreactor and just make a ton of enzyme. Slap it into another bioreactor full of precursor, and boom, industrial scale synthesized cocaine for the masses for medical use.
For the massive medical use. That was nicely said.
This is, because a lot of people need medical use of things.
Yes.
It seems like that, 2 enzymes is a very and 1 precursor. If that's the formula. If that's the arrangement, that's not something that really needs a plant anymore at that point. At that point, you might have some plant that isn't engineered even, that you can just mash up as the precursor and throw a bunch of shit, and then you got put the enzyme in there. And the enzymes, the way the enzymes work, they're a catalyst. So they're going to do a 1 to 1,000 work ratio on this stuff in conversion. I think they should probably have, thought the criminals could never figure it out thing through. Because maybe they just don't know. Maybe
they're probably still missing a few. Yeah, they're probably still missing a few pieces. I mean, from this, it said that there's this, key biosynthetic step for the skeleton of this intermediary, and it was unknown. And now they found these 2 enzymes, and look, it does this, and this works in nicotiniana. Will it work the same in yeast? We don't know. Probably, but perhaps the biological pathways are still not fully fleshed out, and there still needs to be some. I mean, like they said, they didn't make very much in these plants. And so
and they have a very extensive process, but you're also talking about a bioengineered plant is already the hurdle. Like, if you
tobacco.
if you have a mechanism and you can remove the plant from it, then it's the biotech bioreactors could be producing tremendous volumes of this much needed medical. But do we need it medically? I mean, I get it. Like, people are still
it is still used, actually. Yes, it is.
Okay.
Still
to make
used
Coca-Cola. No.
No. No, it is still used around the world for various medical and veterinary techniques. But like you said, there are these other biosimilar synthetics that are not as addictive, not as dangerous, that are used for different uses. But they're not as good all the time. So to be able to have, without having to grow the coca plant, the coca leaves, or having to, rely on drug busts or whatever, you need these medical and research purposes need very, very pure substances. And so where do you get it? How do you have it ethically? How do you have large enough substances, large enough amounts of it to be useful? Anyway, lots of reasons. But, we were talking a bit about ecosystems and how, one change in one place, downstream effects, butterfly effect, woo, 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 what happened elsewhere. Our favorite Parasite potentially has one of these butterfly effects, except in wolves. T. gondii, toxoplasmosis, which is known to infect lots of cats. We've talked, even I think it was last week, about cats being the host of these wonderful parasites. And in cats, it's like, whoop, goes right out. They eat the rats, the mice, the poop, whatever. It passes out in the cat poop, and then the mice and the rats. And anyway, nice life cycle. However,
seals, California seals off the coast of California, when they're found distressed, almost always have T. gondii. When they fail to be able to eat. It's every livestock, half of humans.
But what do wolves also eat? Rodents.
Mice.
Cats?
Lots of them. Cats.
No, the coyotes in my neighborhood eat the cats.
Oh, got it. Okay.
But wolves eat lots of rodents. And so wolves are also very, very likely to be infected with Toxoplasma gondii. And this recent study published has determined, based on 26 years worth of wolf behavioral data, that if a wolf is infected with T. gondii, it is 46 times more likely to become the pack leader. Looking at the behavior of the infected pack leaders and the role of these entire packs in ecosystems, the researchers have gone on to suggest that it leads to changes in the wolf pack behavior as a whole. So not just is the leader of the pack more likely to be infected with T. gondii, its behavior is different, and that's why it's more likely to be the alpha. The alpha influences the others downward in the hierarchy. And so the researchers have said this behavioral consequence means that infected wolves are 11 times more likely to disperse from their pack into new territory. Infected males had a 50% probability of leaving their pack within 6 months, compared with more in typical 21 months. Females had a higher chance of leaving their pack at a faster rate and then becoming pack leaders. This leads to heightened aggression, heightened dominance, which is great for a pack leader, but then it can lead to congenital T. gondii transmission passed from mother to offspring. And so then you can have wolf packs that are congenitally, potentially, more aggressive, more dominant acting, and these aggressive, domineering pack leaders have a big effect on the group decisions. So
okay,
So
this whole
that's
time I was wondering, what is the benefit to T. gondii, right? And
Right.
so you
Benefit.
just spelled it out. So first of all, if you send the wolves away, you're spreading the parasite. Great.
yes.
A+. But
A
the other one
Parasite, woo-woo.
is
No, you're
the
not.
alpha
You're not spreading the
fathers
parasite.
the most babies, right?
Yes.
And
yes.
then then they are propagating the parasite in their babies. So
They're-
that's
Right.
also
they're
a
not.
benefit.
the alpha female,
No.
the alpha male, the alpha female.
But Kiki
is more
just said
likely-
it's
yeah.
No,
congenital.
No,
It is
no,
congenital.
no.
Mhm.
No, hang on.
Yeah,
hang on.
yeah.
Wait a sec. Let's clarify because this runs counter to my understanding of how T. gondii operates completely. So the infected wolf is not going to pass the parasite out to anywhere because the gamete cells do not turn into eggs and it does not reproduce and it does not become.
That's not what this is saying. In this, what they have determined is that females are likely to pass it on congenitally to their
The
offspring.
aggressive behavior or
The T. gondii infection. So
Because they can't
females
infect
are these
in
baby. You know, these
vitro.
are mammals, right? So the babies are in there, the bloodstream,
Yeah.
the parasite is probably getting in through the placenta somehow. Or potentially maybe it's after birth with the milk supply. I mean, there's a whole bunch of possible routes of transmission.
But they're not
yeah.
going to transmit it. Even that pup isn't going to transmit it to the rest of another pack. That does not happen.
No, but
No. Okay.
but you have more individuals in a pack who are potentially infected.
So
Then
the
they
question-
go, screw you, I don't like you, I'm aggressive and dominant, so I'm out of here. And they run away and they go to another pack. And they pass it on to another pack. And so it spreads and yes.
The part of this that is okay. Part of this is very interesting. In human males, infection has been associated with novelty seeking,
Yes.
and so it's
Also
sort
aggression.
of interesting that some of these wolves are like, huh, I wonder what's over on the other mountainside. I'm going to go wander over there. Oh, hey, look, there's other wolves. And then I wonder if it's not. I'm really questioning whether the T. gondii infection is at all influencing aggressive behavior in these wolves, or so once you're in a pack, there's a hierarchy that is fiercely enforced.
Right.
There's a pack leader, and then there's all subservient wolves after that, basically. Except
Right.
for
And
maybe
the T. gondii pack, the T. gondii wolves go, I'm more aggressive. And they become the pack leader because they fight everybody. And then they're like, I'm the
Oh,
winner.
I thought they left and found a new pack. See, 'cause
and
that
then
would
become the pack leader.
Wait. But if you leave that pack, you
But
are
then you
no
go-
They're
longer.
leaving their ancestral pack. They're leaving when they grow up.
Yes.
They're leaving earlier. And then they
Younger,
are
but
becoming the
earlier.
leader of the new pack that they have found.
Which makes
Yeah.
sense. Because once you're away from your hierarchy, you get to start again and try to be top. So I kind of I don't know. It's interesting that they've seen this aggressive thing. I wonder if that's just normal, I don't know, wolf behavior, except that they're being novelty seeking and heading out earlier. But just
The
another
behavior-
reason to get rid of cats.
Well, in this case, it's not cats, it's cougars. And this is
Oh, is it
where,
cougars that are-
yeah, so this is where cougar territories overlap with wolf territories. And that's the T. gondii spread, is the wild feline of the ancestral form that is involved in this. So, go ahead, get rid of all the cats, Justin. Do what you do.
Big cats.
Yeah, okay.
Well, are
there
you telling me
go.
there's
They're
really
already
there's
almost
no
gone.
domestic cats? There's probably herds of domestic cats. I still think it's
Herds.
the domestic
Herds.
herds of
Cats.
domestic
It's not.
cats.
What do you call a herd of cats? Haven't you ever heard of
Non-existent.
people saying, "Oh, it's like herding
A
cats"?
pride.
They don't do that. That's why that phrase is a thing.
Okay, but the bottom line is this is an interesting ecological study showing how a small microscopic parasitic creature can have not only individual consequences in behavior, but how those individual behavioral consequences can also go on to influence entire populations. So
I also think it's funny that there's all these wolf pack leaders out there that are really at their core, they're cat people.
they've been infected with the Tigandii. Oh my, oh my. I hope that we are the leader of the science pack in your world. This is This Week in Science. Thank you so much for joining us for another episode full of science and fun. And this has been a great fun time so far. I know we've got more fun times to come, but let me just remind you right now that this is our annual time to be selling This Week in Science calendars. So if you have not been over to TWIS.org, you can click, let me show you Blair right now. You can click on, you can go to TWIS.org. We have a couple of things. You can click on the Zazzle link with the big picture of the cover art that Blair's come up with. And that will take you to Zazzle, where you can purchase a printed calendar for 2023. And it's beautiful. It's wonderful. The only thing is it just doesn't have all of our science holidays, unfortunately. If you're interested in those science holidays, and that's what really gets you going, if you're in another country and the mailing prices are getting to you, you can alternatively purchase the 2023 TWIS calendar as a digital PDF download and print it yourself. That has all the art, high quality CMYK, beautiful PDF with all of our science holidays, and you can print it up yourself at any place that prints things. You can get it done as a calendar, you can print it on your printer, you can do all the things. It's beautiful, Blair. I love your calendar.
Thank
I
you.
hope. You're welcome. It's Legos, everybody. Lego animals, and it's gorgeous. And I just can't wait to put mine on my wall in 2023. I hope the same for you. All right. Oh, Blair, you're up on the screen right now, so I think I'm just going to leave you right there.
Heck yeah.
Because, this is This Week in Science, and we're going to come back right now to Blair's Animal Corner with Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels, there's Animal Corner.
What you got, Blair?
Oh my gosh. So Kiki, what do you think
What?
an annoyed bat sounds like?
I'm making a really high-pitched sound right now that you can't hear.
Got it. You're exactly wrong.
Oh.
In fact, annoyed bats sound more like death metal singers or tube and throat singers.
What?
Extremely low. This is figured out by extracting, mounting, and filming larynxes from Daubenton's bats and applying airflow to mimic natural breathing. High-speed videos showed vocal membranes and false vocal cords vibrating at different frequencies. They were able to find the extremes of possibility in these bat throats and found that the lowest to highest was 7 octaves. Most mammals have a range of 3 to 4. We have generally 3. If you're looking at Mariah Carey or Prince, they have 4 or 5, but there's only a few humans that kind of reach that threshold. So mostly we're looking at 3 octaves for us, but they have 7.
Whoa.
And so this is a video of them looking at kind of forcing that air through the larynx. So what they found was that specifically these growling sounds are produced when bats fly in or out from a densely packed roost. So they're like bumping into each other a bunch. And the low sounds are in the range of 1 to 5 kilohertz. They seem to be aggressive or an expression of annoyance. And then there was kind of this third category of, I don't know. So there was aggressive grumbling, there was annoyed grumbling, and then... So there's at least one more category of why a bat would make this deep death metal sound. They are doing this with false vocal cords. They look like vocal cords, but they are not used in normal speech or song in humans. In death metal and in Tuvan throat singers, they use false vocal cords just like these bats are using. They move. If I were to do it, if I were to scream some death metal right now, which I will not, the process would move the vocal cords down so they oscillate with these vocal folds that are these false vocal cords. So that together makes the vocal folds heavy, and that makes them vibrate at extremely low frequencies. Meanwhile, when bats are echolocating, they make extremely high frequency echolocation calls. They do it by vibrating very thin vocal membranes, structures that we no longer have. We lost them over evolutionary time, but bats retain them. They, by filming them at extremely high rates of up to 250,000 frames per second, they have the ability to vibrate extremely fast. And so that high frequency call allows them to echolocate, which allows them to catch their insects while flying. So they're still trying to figure out what the meaning of these sounds and calls are, as I mentioned, but it's interesting that it is a similar method, what's happening in their throat as far as we can tell, as stuff that we do as humans. So
Except they're... Except whoa, 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 whoa.
Yeah, exactly. They do.
I need to know if they get throat polyps, because that's like
it's
an issue.
Are you talking about from all the vocal fry?
Yes, and also these vocalists who everybody's having to sing louder, but nobody's using the techniques anymore to protect their throat, and so there's a lot more scratchy kind of stuff and vocal fry that it's anyway, yeah.
Or maybe bats just don't live long enough for it to matter. I'm sorry, it might be the case.
That's probably more likely. Gosh darn it.
That's the sad reality of most animal species.
Long live the bats.
Yeah, but there you go, 7 octaves.
That's a lot.
Well, that is wild. I think you listed off some people, some humans who have the crazy vocal range. So
but
Axl
that's
Rose
only 5.
Guns N' Roses.
Yes, Axl Rose was another one. Yeah,
he had a crazy range. But
he also had 5.
I'm at least
what
glad
about the singer from the Fifth Element?
Oh
yeah.
Yeah, I don't know. I don't know how any.
I'm at least glad that Kiki's first impersonation of bats is the only one that I've heard. The squeak squeak sound. Because can you imagine if bats were just flying around? Gosh, the bat! Oh, there's bats.
We might be a little more afraid of them. Yeah.
More or less, I don't know. I wonder if the high pitchedness makes them feel creepier to some people. I don't know. It's like screaming. It's like bats. Grating. But I guess death metal to some is also grating. So I don't know. It's the worst of both worlds. Moving on to the worst. Let's talk about Canada geese and their poop. I live in an area filled. They're lousy with Canada geese. Every time I walk my dog, I step in so many goose poops. I have to prevent her from eating a random one. If you walk through the grass, they're everywhere. And then sometimes the geese will hiss at me and chase me and my dog.
What? Of course they do.
Yes. And so Canada geese are widely considered nuisance birds for the poop problem, for the attacking problem. And generally because they're not supposed to hang around here all the time. They are supposed to be migratory birds. They're supposed to get the heck out of here in the winter. They fly south for the winter. They fly further north in the summer up to Canada. And they usually just stop by on their way north and south. That's it. They're here for like a couple weeks tops. They scoot. But they have stuck around. They've figured out where they can hang out. There's a temperate climate. There's steady food and shelter and not as many predators, often in urban areas. And so they stick it here. They completely give up migrating.
Yeah, it's all the fault of one old man who would go out on
and feed
early
them
in the morning, sitting on the bench, throwing stale bread out there to the geese.
Certainly possible.
They never left.
Yeah, and so there is a huge industry, both for profits and also in the academic community, trying to figure out how to encourage these buddies to fly south. Just do what you're supposed to do, kickstart your migration, get the heck out of here. So, University of Illinois put little Fitbits, little GPS transmitters around Canada geese on their necks like little collars to see how their behavior changes when harassed. And harassed is an actual wildlife management term, just like hazing is a term when you're talking about some other species like coyotes. So harassing geese is what you do when you encourage them to move out of a space. You do not threaten them with actual harm, but instead, in this case, you walk or you drive towards them while clapping boards together to tell them to scoot, to kind of just spook them. And so what they found was that harassed birds spent a little more time flying in an alert mode than geese that weren't harassed, but their GPS collars told us they spend the same amount of time foraging and resting. The point of harassing the geese is to stress them out enough that they can't rest so that they are running out of reasons to stay and they start to use up their energy reserves. So they are forced to move warmer and to a different area with better resources. So that would encourage them to get the heck out and go south. But it turns out they're actually returning more quickly to the places they're scared away from. Whereas when geese leave in the absence of harassment, they stay away longer to make use of resources elsewhere. Most harassed geese either moved elsewhere in the same park or were back within the hour. And when they did leave, they went to rooftops, rail yards, other parks, water treatment ponds, and sports fields. All other human-used spaces.
And not necessarily
south for the winter.
Yeah, and not necessarily places that are like good for food or they're just open spaces.
Yeah, but also one of the ones that I thought was particularly interesting was a water treatment plant. Perhaps a place you definitely don't want a bird sitting in the water and pooping. But anyway, so it didn't work. And I will mention that this is not the first study to find that harassment doesn't work, but it is the first to potentially explain why harassment doesn't work. And the idea is that when you harass them, they fly a little bit because you scare them, or they might be alert a little longer, but it didn't change their energy output enough over the day to make them hungry or cold, which are the main kind of points of this, right?
Or to convince them that like this is a bad place to eat food. Like the food is no good here. You must find food someplace else.
And it just didn't do that. No. Also, by them having the GPS collars, they were able to collect data on the geese during really bad weather. So this was in Chicago. So there were times when it was just so crazy cold and snowy that the researchers couldn't go out there and harass geese. It wasn't possible. But because they were wearing GPS tags, they could still track what the geese were doing. And what they found was that during those really cold and snowy times, the geese are in fact just resting and waiting out the weather. So if you could harass them during those times, it's possible that that would actually encourage them to leave.
And
That
go
deserves
where?
future testing.
Yeah,
South.
and
You gotta go south.
go. It's bad weather here, everybody. Leave.
Yeah, exactly. But the other thing that nobody wants to talk about, but is mentioned towards the end of this, that I will also mention, because it's an important thing to discuss, is that this is all under the confines of no lethal element to a deterrent for geese. And they are extremely smart. They're adaptable, they have excellent memory, they have a keen ability to discern legitimate threats from mild annoyances. If you are not killing birds, they know they won't be killed and they will come right back.
Okay,
So-
well then that brings up the question: what have you been doing to your local geese, Blair? That
I
they're
have not done
all chasing
anything.
you and your dog.
But there is a piece of invasive species management, which Canada geese are, because they are not supposed to be here year round. They are infringing on a habitat and a food web. There is a piece of that where sometimes you have to talk about eradication. When you do that, if you can do that in a targeted way to discourage geese, if you can figure out that lethal harassment, which sounds terrible, but if you are able to eliminate a couple birds and then the rest of the flock recognize this is not a safe place to be and they leave, that is a potential way of looking at this. Obviously, that is a really controversial topic. Not a lot of people want to talk about that. It is a big bummer. You don't want to kill animals that are otherwise healthy, that are just minding their own businesses, pooping it all over the place. But sometimes it's necessary, especially when you're talking about animals that disrupt ecosystems. If they're just pooping everywhere and you're stepping in it, that's not a reason to kill geese.
Right. And so this is the question, is the
Yes.
amount of ecosystem disruption that's actually occurring because of their presence. And at what point does, in the idea of migratory species, and also with just species in general, remember that everything has blurry, fuzzy edges. And at one point in time, migratory species were probably not migratory. Or maybe they were nomadic and they just followed food. And so there's no reason why a migratory species couldn't also go back the other direction. And it seems as though the Canada geese are becoming more nomadic and actually finding places that work just fine and maybe traveling on when they want to go. Or there are some populations that are just staying where they are. And now, whether or not we determine that that is invasive and bad or a part of just the changing ecosystem, the fact that we have created habitat that is suitable to the geese because of our human habitation. I mean, come on, everybody. There's so many pieces that stick together.
For
here.
sure.
Something like this came up recently. We're walking around a forest here, and I saw a pigeon. And I was like, oh, you must be lost. Because I'm so used to seeing pigeons in heavily urbanized areas. You know, there's like 1,000 of them at the Central Copenhagen train station, or the one right off of it. They're all over San Francisco. You see them all over the streets in New York. Then I saw a pigeon in a forest park. And I'm like, oh, poor guy must be lost. Doesn't belong here. Because there wasn't a giant fly. It was like, just one pigeon wandering around. I was like, oh, gosh, poor guy. Because I just assume that they've always lived in cities. Like, where else would a pigeon be? But in near a train station in a big...
They're doves, baby!
But so ecosystems change and strategies will change over time, and so we shouldn't be too surprised that the geese like the airport runway or the golf course or the local park or wherever they're hanging out, if they found a niche that's working, they should stick with it.
Right. And so that's really the question: is it impacting local environments, or is it just a nuisance for humans?
Right. And you mentioned that these geese are also very intelligent, and it has been suggested that more intelligent species are more likely to be generalists, and generalists are more able to adapt. And
Yeah.
And
Yeah,
just
imagine
not for
like,
nothing.
hey, buddy, I don't have to fly 6,000 miles every year
Yeah.
why? Why
to
would I
get
do that?
food and
Somebody
stay warm.
came-
I can do that here.
I'll just
Why
stay
would I
here.
leave?
It's all good.
Yeah.
And it's just a last thing to throw out there. There used to be a lot more wetlands and places for geese to go that maybe
Stop
did,
along
you
the
know,
way. Yeah.
Yeah, and that maybe did resource-wise dry out seasonally, and was why they needed to move. And now if they don't need to move because humans have been are providing a stable environment, then we've created a biome that is, like, how do you even have an invasive species in a park? Like, how is there an invasive species? How is that even a relevant thing to say in a place like the San Francisco area? Because nothing there is the natural environment anymore anyway.
The Canada geese, they say, I'm just a tourist, This is This Week in Science. Hey, Justin, what do you want to talk about?
Oh, gosh, do I still have stories I haven't talked about?
Yes.
Oh, I'm missing one. Oh, here we go. Yeah. Nearly 300 years ago, I think that's more than 300 years ago, in 1713, a collection of fake Roman coins was discovered in Transylvania. At the time, these coins purported to be around 1,500 years old. So they go all the way back to around 260 CE. It featured a Roman emperor, Sponsianus. For much of Roman history, Roman mints produced coins featuring portraits of their current emperors. Only problem, no such spontaneous Roman emperor ever existed.
Ooh, fake
Adding
coins?
to this, the coins seem to be manufactured differently than other coins of the mid-200s, being cast rather than stamped. There were some stylistic issues. It was the style of a Roman coin, but it seemed too crude. So the forgery was obvious. One problem with the forgery being a forgery, however, was the question of why would someone make a fake coin of a fake emperor? When you could make a fake coin of a real emperor, and people go, I'll buy that for, $1. And reason it turns out is because they might not be forgeries at all. Not entirely, anyhow. So a new analysis suggests that these long-thought fake coins are authentic to the 260s, providing evidence that the leader portrayed was power, at least somewhat. Paul Pearson, University College London, UK, and colleagues present their findings in the open access journal PLOS ONE. Pearson and colleagues applied visible light microscopy, ultraviolet imaging, scanning, electron microscopy, and reflection mode Fourier transform infrared spectroscopy to the coins for comparison to undoubtedly authentic Roman gold coins. See, I think these coins are gold. You made fake coins out of gold with a fake emperor. Real gold out of anyway. The analysis revealed
It was their Bitcoin, right? Or they're making
in a way
their
it
own
sort
version.
of was. The analysis revealed deep microabrasion patterns typically associated with coins that were in circulation for an extensive period of time. They also analyzed earthen deposits on the coins, finding evidence that after extensive circulation, the coins were buried for prolonged periods of time before being exhumed, all suggesting the coins are authentic. Problem is,
They're tokens. They're game tokens.
Anybody who's
right.
golden game tokens.
Yeah.
Anybody who's like
Caesar's
studied these
Palace.
people who are experts in Roman history and everything have always said that this is like they're made wrong. It's not the right style. This emperor doesn't exist. Like none of this fits. So the researchers, though, considered the historical record alongside the new evidence of the coins, and they now suggest that Sponsian was an army commander at an isolated gold mining outpost in the Roman province of Dacia, which is a territory overlapping modern-day Romania. During a time when the Roman Empire was in the midst of civil wars, there were borderlands being overrun by plundering invaders, and very likely they were cut off from the chaos even that was the Roman Empire for a number of years. So what we may have here is a self-proclaimed emperor casting coins far from the official royal Roman mint with an artist who's not maybe up to snuff with the artisans back home. And this guy's, he's got this isolated gold mining outpost. They probably didn't have a whole lot of highly qualified artisans, so that might explain the crude rendering, the need for casting as opposed to having a pressing mint. So maybe more of an acting governor due to this loss of contact with the normal chain of command sort of thing, trying to keep order and saying, we're going to have some normalcy. I'll be the emperor for now. Or perhaps he was an ambitious commander. This happened quite a bit in ancient Rome. Somebody would gather some wealth. He's got his own chain of... He's got gold mines all over. He's like, hey, you know what? Like this, I could take Rome one day. Rome's in chaos. Why don't I just call myself emperor and come back? But eventually, it would be Dacia would be evacuated by Rome and then abandoned within a few decades after that. After the minting of the coins, most likely. So this is most likely, I think, the local commander attempting to keep order in a tumultuous time. But very interesting how nothing fit, everything's wrong, it's a fake coin. And it turns out it's a real coin, there's a real story behind it, and there's now a piece of, I guess we're now Romanian history of this isolated gold mine outpost commander who made himself emperor just by saying so. Which is also the whole thing about the transition to power and why that's really necessary to have a very clear goal. Because I guess anybody with a gold mine could call themselves emperor or president or whatever they want.
And that's what used to happen on the, in the colonies, early days, company towns, right? Coal mines, you'd work at the coal mine, you'd get the money that was minted by the owners, and everything was bought in the company store. Very similar kind of
16 tons, what do you get?
Another day older. It's also
deeper in debt.
Not the only, you talked about colony times. This was a very much
not colony,
a phenomenon
industrial, but yeah.
Okay, but this is also very much a phenomenon of the Pacific Northwest lumber towns, or some mining towns today, where
a lot of times
it's not Fortuna, is it? Maybe it is Fortuna.
Anyway.
It's a small town up in Northern California, doesn't matter where the lumber company printed the local newspaper, was in charge of the local newspaper, and rented the housing to the lumberjacks. They owned the houses in town and would rent it to them. So it was very much that company town where all the money cycles back into, all the information is given by. So that sort of thing has gone on so recent history.
It's been
last
going
on.
Night, yeah.
From me, last story from as a team of researchers have discovered at least 2 new minerals that have never been seen on Earth before. They found these naturally occurring minerals in a 15-ton meteorite found in Somalia. Wow, 15 tons. It's the 9th largest meteorite ever found on the planet. Whenever you find, this is, who am I quoting
15
here?
tons, and what do you get?
Another day older and deeper in debt.
No, 2 new elements or
Two not elements.
No,
That would be
minerals.
really exciting.
2 new minerals.
2 and possibly a third. So this is quoting Chris Hurd, professor of the Department of Earth and Atmospheric Sciences and curator at the University of Alberta's meteorite collection. Whenever you find a new mineral, it means that the actual geological conditions, the chemistry of the rock was different than what's been found before. That's what makes this exciting. In this particular matter of 2 officially minerals that are new to science. 2 minerals came from a single 70-gram slice that was sent to the University of Alberta for classification, and there's a third mineral that is under consideration in their sample, so there might even be 3. They say if researchers were able to obtain more samples of the mass meter, more. So the 2, this is sort of, so they brought in an expert. He's like, okay, I got this analysis. They're bringing the expert, and let's see. Heard was analyzing meteorite to classify it. He saw something that caught his attention. He brought in the expertise of Andrew Lecoq, head of University of Alberta's Electron Microprobe Laboratory. And quoting Heard again, the very first day he did some analysis, he said, "You've got at least 2 new minerals in there." That was phenomenal. Most of the time it takes a lot more work than that to say that there's a new mineral. Part of the way that they identified these new minerals is that they had actually been synthetically created before, so they could match it there. They did still get to name them, though, because this is the naturally occurring, I guess, versus the human-made counterpart. Which is also like one of those things that in science fiction, they're always out there mining asteroids or mining somewhere. And I always thought, like, why would you need to go mine an asteroid or meteorites in space or whatever? Like, it's just minerals. You could produce everything. If you can go to space, shouldn't you be able? But geological processes from cores of old planets or old meteorites and stuff in space and how they form. Abundance, then, of course, is the key. How much of it has been formed under these maybe intense processes.
Maybe
far,
more
far
than
away.
what's here on Earth. And if we can go mess up an asteroid that doesn't have any life on it that we know of, instead of messing up the ocean seafloor or our mountains, oh my gosh, I'm all for it.
So researchers are continuing to examine the minerals to determine what the conditions the meteorite was formed in. That is my expertise, says Heard. How you tease out the geologic processes and the geologic history of the asteroid this rock was once part of. I never thought I'd be involved in describing brand new minerals just by virtue of working on them. He notes that the new mineral discovery could lead to exciting new uses down the line. Whenever there's new material that's known, material scientists are interested too because the potential uses in a wide range of things in society. Researchers have unfortunately not been able to get additional samples. They have received news that the meteorite appears to have moved to China. The 15-ton meteorite has moved to China. Apparently it was sold or is in search of a potential buyer. So it remains to be seen whether any additional samples will again be available for scientific purpose, or hopefully if it sells in China, hopefully at least it gets studied there. But
but now that we
sorry, last thing is it's interesting because apparently this meteorite has been there for several generations. It didn't just land; it's been there, many generations that things been known about. Then they find it, they go, oh, wow, we've got this. I'm like, who gets to sell that? Is it the government that's selling it? Is it somebody whose farm it landed on? Like, who's getting to sell this 15-ton meteorite? But apparently it's gone. It's missing.
These things are for sale. People buy and sell these things. There's a massive market. I mean, there's the whole TV show, Meteorite Men, and people who go out and search for meteorites so that they could be the people who found them and then sell them for lots of cash because they're big collectors. And in a case like this, potentially it'll be researchers and others who are interested in it.
15-ton. Do you find one buyer or do you break it up and just sell it to like, how does that work? I don't even know.
I think people would want the whole thing. I mean, if it's like that massive, I have no idea. I'm not I only have like a couple of little teeny tiny meteorites in my collection so far.
Yeah, if you're Mini Museum, not to plug a company, but if you're them, you knock off tiny little pieces and you sell those off.
But I think the interesting thing is if we have these new minerals, if we know what they are and know what their makeup is, then it becomes the job of chemists, of material scientists to determine how to synthesize them. Can we synthesize them? What kind of forces would have been at play to create these minerals and the particular combination that they have discovered? And then that gives us information on the history of the universe. And also if we've got, synthesis, then what can we do something with this? Is this useful? Is this a new material that we can do something with?
And so apparently 2 of them have been synthesized. I think the holdup on calling the third one a new mineral is that it hasn't been. Otherwise, they would have been able to recognize it, right? So there's a third potential new mineral that is not just unfound on Earth before, but unseen. Undiscovered on Earth before also.
They haven't pictured it yet. They have to stick a nice picture and go, this is different. This picture doesn't look like those pictures. Okay, I have a couple of last stories for us to end the show. And Blair, we're going to talk about octopuses right now.
I'm very excited because I have to tell you, I read this story and I wanted to bring it, but I didn't understand it. So... So I'm so happy that you're going to explain it to me right now.
Yes. So it's not just octopuses, but the octopus nervous system. We've talked before about, how there's, the octopus brain, basically, that consists of like a central brain, and then how there's kind of like little separate brains out in each of the arms. And Blair's told us about how different arms have different uses, and we've heard all this kind of stuff. But what is not known really is how the different arms potentially communicate with each other. Historical research done back in the 50s was able to determine that if you lesion brain areas in the octopus and you mess around with an arm on one side of the octopus, you can still see arms on the other side of the octopus responding. So how would that happen? If you lesioned brain areas in the middle that would supposedly be responsible for communication between the different arms, how could they be responding to that movement? So these researchers published in Current Biology their work on little tiny octopuses, these little little small octopuses in this study that was made possible by the Marine Biological Laboratory. These little young octopuses were small enough so they were able to image the base of all of the arms at the same time. So if you imagine, there's the blurby head, body part of the octopus, and then the 8 legs splay out from there. But there's something of a ring. And so these researchers were able to then take the tissue, image it, and process it so they could color different parts of the musculature and the nerves that are in these arms. And they found that at first they were looking at these larger nerve cords that are in the arm. And the larger nerve cords, they're like the nerve cords that are responsible for the movement of the arms. But they determined that there are like other nerves that are involved that they were calling intramuscular nerve cords. So these are inside the muscles doing different things, and they help with proprioception, or the sensation of the movement. Like, oh, I know where my arm is in space. It's not just randomly flapping around. I actually know what it's doing and where it is.
And
So
it's throwing rocks at other octopuses.
it's throwing rocks at other octopuses. And so they've thought that these inks these intramuscular nerve cords have been involved in proprioception for a really long time, but then they were like, all right, let's really look at them and how they're involved in the arm control and what's going on. Let's trace them through the tissue. And what they found is that instead of just ending at the end of an arm and going into the brain, the main brain, or just being part of the arm itself and nothing else, that in fact they crisscross. And each arm is connected to an arm on the opposite side of the octopus's body.
That's awesome.
And so this is a new design for what they're calling a limb-based nervous system. So that the limbs probably created the basis for the nervous system because of the need of movement and the need of knowing what's happening in their environment, and the limbs being like a tongue, the limbs being a hand, the limbs being a foot, the limbs being, everything.
When you're all limb,
yeah,
it's
a good
immediately
design.
making me think of sea stars, because
Yes.
sea stars like sense and taste and see and move and do everything with their, technically thousands of feet that are little hydraulic feet along each arm.
right, all the different feet. But in this particular case, it's not like they're connected in a very interesting pattern because they skip. It's not like the nerve cord in one arm goes into the arm right next to it. It skips a couple of arms and then goes into the third arm from it. So there's this symmetry, radial symmetry of the way that the web of the nerves is connected. And so that's why in the 1950s, when they got rid of the brain and they stimulated one arm, a symmetrical arm on the other side still wiggled and responded. It was because they're connected for that proprioception. So now, of course, robots, can we use this to help design robots? And also, what can understanding how the nervous system of octopuses has evolved and how it functions, what can it tell us about nervous systems in general and possible other body plans and formats for other intelligent creatures, right?
And also, can we decentralize my brain?
Yes. I think it really hits on the point of the embodied cognition, which has become much more prominent in neuroscience and cognitive biology over the past few decades. But the whole idea that it's not just your brain that's important, it's actually your body and your brain working together to connect you. And so when you talk to a therapist and they talk to you about where do you feel your feelings? How do your feelings feel? Blah, blah, blah. It's not just because they're not just asking you that just because. It is because there is a mind-body connection. We've talked about our gut being connected to our brain. We've talked about, we know that all these things, we know it. All these things are connected. But octopuses have a much different plan, and it's fascinating.
it seems like a good form of delegation too.
Right.
So, if the brain had to focus on all 8 limbs at the same time, that just seems like a lot of work. Like you wouldn't be able to think about anything else.
Yeah.
Just walking with 8 limbs. But they don't use all, right? No. When they walk, they use don't they like have specialization in certain limbs to do certain tasks?
I'm just
So I'm
curious
wondering
about the one that's symmetrical to the mating limb.
Exactly.
Yeah.
Does it have a paired function, or does it do they tend to work in tandem with that paired tentacle?
Right. I call that the hexacaudal less
Yeah.
opposed to the hexacaudal more, right? No? Okay.
No, that one was.
That's for those cephal enthusiasts out there.
Yeah. So anyway, octopus anatomy and neuroscience. Very interesting. We may understand this new embodied organization for octopuses and their behavioral control. Oh, and now let's talk about bird jaws. Dun-dun, 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 dun-dun. Ba-da, ba-da, ba-da. It's not Shark Week. No.
They don't even have teeth.
Well, these birds did. So we're going back in
Yikes.
time. Sit to
Like
60.
an angry, pointy.
Yeah. We're going back.
What's it called? Auk.
It is kind of an angry, pointy auk. Yes. But we're going back in time to right before a lot of dinosaurs died. So about 66.7 million years ago or so. And there's an image that has been used by The Guardian that is the product of... Who did this? Who did this wonderful picture? This picture is Philip Krzeminski. And it's an impression of the last known toothed bird that researchers have named Cannabis finalidens. And in this image, Cannabis finalidens, who Blair has said does look like a toothy, pointy auk, is playing around on the beach with a bunch of wonder chickens. Now, wonder chickens that's the nickname for the oldest known bird, the ancestor of modern birds. And when we think about birds, like when we think about the way that their jaws are put together and the way that their beaks work, lots of modern birds, songbirds and others, you see them preen and they're like, and their beak moves. Mm-hmm. But you know what? Their mouth is not set up like ours, where our upper jaw is like fused to our skull and our lower jaw is the part that goes and moves around based on the muscles, right? No. Lots of modern birds have movability of their upper and lower jaw. That's why their beaks are like their hands, right? Because they're like, I can move my upper, I can move my lower, I can do all sorts of things with these cool beaks. And we always, not we, but bird researchers, evolutionarily speaking, have thought that's a modern thing. This is just modern birds. Older birds like ostriches and others, theirs are more fused. They have a fused jaw condition. And so these mobile upper jaw or mobile palate birds are called neognaths or new jaws. And the fused palate ones are paleognaths or old jaws. So we've got new jaws and old jaws. And this bird, Cannabis finalidens, is now named because they were looking at fossils and they went, look at this, look at all these things. Oh, look, there's this bone here, the pterygoid bone. And the pterygoid bone in a lot of these old-jawed birds, it's fused within this complex. It's all fused in there. But very often, this bone is broken and in multiple pieces. And so researchers just thought it was fused in all sorts of birds. And that these old birds always all had fused jaws. Because the fossils that they found, they're damaged. And this pterygoid bone has been broken. And so they're like, oh yeah, no, they're all fused. Old birds, fused jaws. Modern birds have the movable palate. Well, no. This Cannabis finalidens, which is a reference to the Roman god that looked both backwards and forwards, and also it's the finalidens is a portmanteau of the Latin words for final and teeth, and it existed right before all the birds with teeth got wiped out with the dinosaurs, and they had a movable jaw. That's what the fossils say.
So, Kiki,
And this is
does this mean
67-ish million years ago?
Yeah, that's 66, 67 million years ago. Yep.
So does this mean the ostrich fused their jaw later? Or multiple shoots of birds lost teeth?
This is the interesting question. Yes. So the loss of the teeth, why did they lose their teeth? Why did the jaws get fused? What was going on? Because apparently the fused jaw wasn't the ancestral state. But maybe the teeth and the mobile jaw together somehow didn't work out for these birds. I don't know. Wonder Chicken made it through. But Cannabis did not. Yep. They think that this mass extinction event was highly size selective. Large-bodied animals in terrestrial environments did terribly across the mass extinction event. Cannabis weighed about 4 times as much as Wonder Chicken, so that might have been one thing against it. And other researchers say that if this is a primitive feature, the palate being movable, then it probably could have had an even earlier origin and survived from there onwards. So, bird evolution potentially turned upside down by a broken fossil bone that has been overlooked by researchers forever.
Rewrite those books, those textbooks.
That's just basically
So-
it. Yes.
Okay, so hang on. So I got a couple things going on here. So
Yeah.
I got toothed and untoothed birds in the ancient world.
Yeah.
And the toothy birds have the modern bird beak palate,
Yes.
but the toothless bird is fused. Is that right?
Yes. Yes. Fusey. Yes.
So then then the whole which made it through
And why?
that
Or
the
or
bottleneck event.
did they lose teeth and then some got them back again and then they lost them again? Like,
How many
was evolution
times?
like, let me try one more time?
And
Yeah, I mean,
were
we
there-
know chickens still have the genes to produce teeth.
The
They're
teeth.
silenced.
Right. Yeah. Yeah. So many interesting questions here. Where did it start? Where did the teeth? Where did the mobility in the jaw come from?
Well, and also, the
Were there other
mobility
tiny
jaw-
birds? Yeah.
Having a mobile jaw, to me, feels like you wouldn't need teeth then. I mean, I guess
Potentially.
if you have really good muscles, but like in terms of chewing, I guess birds don't do a lot of chewing. They do a lot of swallowing. But
Glop, 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 glop.
but yeah, I don't know. It just seems like you don't have the same bite force if you have movable muscles on top and bottom. Although parrots have some of the strongest PSI bite force in the animal kingdom. So you know what? Never mind. I don't know what I'm talking about.
And sharks. Sharks have a upwardly mobile jaw. Their whole bite isn't actually connected to their skull. I don't think exactly, right? Don't they have these teeth that go up and down? Can't they bite? I think sharks are like that.
Interesting.
I love the language in evolution and ornithology papers pulled together. I mean, you come in here. I mean, this is anatomy, evolution, and ornithology. And let me just read to you the last couple of sentences. We recovered Cannabis as the first known well-represented member of Ichthyornis, other than Ichthyornis, clearly substantiating the persistence of the clade into the latest Cretaceous. Cannabis confirms the presence of an anatomically neognathous palate in at least some Mesozoic non-crown ornithorines, suggesting that pterygoids similar to those of extant Galloanserae may be plesiomorphic for crown birds. Our results, combined with recent evidence on the ichthyornithine palatine, overturn long-standing assumptions about the ancestral crown bird palate. and should prompt reevaluation of the purported Galloenceran affinities of several bizarre early Cenozoic groups, such as pseudo-toothed birds, Pelaginornithidae. I love scientific language. It's tongue
but then
twisting
I'm also learning
and
today
specific.
that the ostrich jaw is fused.
Yes.
Is that right?
Yes.
Yeah.
Fused.
But it also
I
doesn't
can
have
confirm.
teeth. Thankfully.
No teeth.
I got bitten
Very
by one.
thankfully.
I got
Yeah.
bitten by one once, and I on my finger, and I reacted as though I had just been, bitten by a dog or something.
Was that with
'Cause
me? It was, right?
Yeah. I
Yeah.
was feeding the ostrich, and he got my finger because it was
I
aggressive.
encouraged you to let the ostrich bite your hand. Because it doesn't hurt.
No, but it was you went really fast, and it was scary. But yeah, no teeth. No teeth.
No teeth.
Which-
No
teeth.
teeth. As long as the ostrich didn't kick you, you're probably okay.
Right. Yes. Which, not for lack of trying on this end, but
No. Well,
luckily.
this episode obviously did not include a humorous bone, but we have made it to the end of the show. I think.
Uh-huh.
We did it. We made it to the end of another episode. Thank you
Oh,
all for
wow.
joining us for this episode of This Week in Science. We've really enjoyed getting to spend this time with you and have these conversations. I want to say thank you to Fada for help with show notes and social media, to Identity 4 for recording the show, to Gord and Arenlore and others who help keep our chat rooms very nice places to hang out. Everyone in those chat rooms, thank you for being a part and chatting while we've been doing this live stream. And I'd love to thank our Patreon sponsors. Thank you to Teresa Smith, James Schaefer, Richard Badge, Kent Northcote, Rick Loveman, Pilar Velazarb, Ralphie Figueroa, Jan. I'm going to just be pronouncing things like scientific words and names and making John Ratnaswamy, Carl Kornfeld, Karen Tozzi, Woody MS, Chris Wozniak, Dave Bunn, Vigard, Chef Stad, Hal Snyder, Jonathan Stiles, aka Don Stylo, John Lee, Ali Coffin, Gaurav Sharma, Reagan, Derek Schmidt, Don Mundus, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles Jack, Brian Carrington, David E. Youngblood, Matt Bass, Vote Beto for Texas. I'm going to change it for December because that's when I update the lists at the beginning of every month. John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Z, McKen Hayes, Christopher Rappin, Dana Pearson, Richard Brendan Minish, Johnny Gridley, Remy Day, Flying Out, Christopher Dreyer, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Philip Shane, Kurt Larson, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Aaron Mishkan, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul D. Disney, David Simmerly, Patrick Pecoraro, Tony Steele, and Jason Roberts. Thank you all for your support of This Week in Science. And if you're interested in becoming a Patreon supporter, head over to twist.org and click on the Patreon link. Additionally, while you're there, you can buy a 2023 TWIS Blair's Animal Corner calendar, either in print or as a downloadable PDF. Woohoo! On next week's show,
we will be back Wednesday, 8 p.m. Pacific time, broadcasting live from our YouTube and Facebook channels, and then again at 5 a.m. Central European time on Thursday.
Yeah, or simultaneously. Yeah.
Simultaneously in 2 different days.
Yeah. Want to listen to us as a podcast? Maybe while you travel from one time zone to another? Just search for This Week in Science if our podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twist.org. And you can also sign up for a newsletter.
You can also contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twist.org. Just be sure to put TWIS TWIS in the subject line, or your email will be spam filtered into a hologram of a model of a wormhole that maybe exists and maybe doesn't, and so we'll never read it.
It might collapse.
No, other places we probably won't read it. Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy.
No. All right, everybody. This is the after show. Blair, isn't that a beautiful calendar?
That is my extinct animal for this year. It is the extinct Death Eater bat.
I love the bat. I love it.
Necromantis atticaster. It's a really good genus species.
I mean,
Very fun.
anything with the genus Necromantis.
Oh, yeah.
My cat wants attention, but she doesn't. She's like, love me. But don't love me.
Sadie's pining for Brian out the window.
Oh.
He just left.
Sadie, where'd you go?
Also, by the way, every month has some hidden surprises in it. So you'll want to print it out or get the printed version so you can look at it up close.
Well,
So
yeah,
you can find all the Easter eggs.
Where are the Easter eggs? Noodles, thank you for ordering calendars. I hope they print soon as well. Yes, Schnago, we welcome our robotic cephalopod overlords. Cthulhu bot. That is how it will be. It will. Earlier in the chat, somebody, like way at the beginning of the show, said that they had been listening to us in prison, and that our podcast brought them a lot of good news while they were doing time. Now they're out. That's pretty awesome. I'm
Amazing.
glad to have our science help anyone get through any day. Yeah.
Happy to keep company.
Yeah. I'm happy to keep company with people through science. Yes.
Yeah.
All the good things. I like to bring all the good things. And even when it's the things that we can't control and that we're like, oh, I don't know about, we can try and find some positivity and goodness in it somewhere. Somewhere.
Look at this movable upper and upper palate.
Yeah.
Movable palate.
A neonath.
there.
Neognath.
Neognath. Oh.
Neognath.
I added Justin back and then he left.
Oh, where'd he go? He's making coffee.
Yeah. I can confirm macaw bites hurt.
Ugh, I love all the parrots, the Aussies. I'm like, you're so pretty, you're beautiful,
Yes.
I love you. But I keep all the distance because I'm terrified of their bites.
Yeah,
Terrified.
you can straight up lose a finger.
Yep. And people are like, oh, it's just a sweet parrot. And I'm like, no,
Yeah.
nope. I don't know that parrot. That parrot doesn't know me. It's going to bite my finger off.
Yep. Like if you ever watch them crack a walnut like that, imagine what they do to your finger.
I know. They will.
Mm-hmm.
Parrots.
Justin, you're muted.
I bet they eat lots of fingers.
Just
We
wanted
don't
to do a
eat
quick
them.
shout out to
They're
John
herbivores.
Michael in the chat room.
Yeah.
Glad we were there to help.
Yep. Agreed. Very much. It's been interesting recently.
That's a
Everyone
tough-
was really
tough
upset.
situation.
Everyone was upset that squirrels. There was a picture of a squirrel eating a rabbit ear, and like this
Oh, yeah.
squirrel. The
What?
squirrel's like nibbling on a rabbit ear, like you would nibble on a carrot. I don't know.
Ugh,
Yeah,
why
we've
were
talked-
you
we've
looking
talked-
at that? Look away.
It was on social media. Everybody was like, "Oh my goodness, look at the squirrel eating
Is
a
that-
rabbit ear!" And then I was like, "Of course, it's an opportunist. It's not. It just wants to eat something, you know."
Certainly.
I bet, you know, cows eat rabbits and squirrels and everything. We think
Yeah, I mean, deer eat meat in the winter.
deer eat meat, like all these, like we're like, oh, they're so wonderful, and they're just vegetarian. It's totally. If there's food to be had, there's food to be ate.
Wait a second.
Oh yeah,
Wait.
for sure.
Cows will eat meat? Because I'm a
Yes,
strict.
cows will eat.
That's
gosh, I
that's
might
how
have to-
Mad Cow happened. They were feeding cow
Bloody-
to cow.
Oh, yeah, well, they were
bloody
feeding
cows.
them sheep. Yeah.
Yeah,
No,
it was like pellets or food, whatever. Probably
It was
not pellets,
processed.
actually. It was
it
processed.
was processed, but
Yeah.
it was basically like the waste meat from
Yep.
other livestock. So
Oh gosh.
Birds eat eggs.
yeah, I mean,
Birds eat other
animals.
birds.
I mean,
So-
mice are supposed to be herbivores, and mice will get up to some nasty stuff when you're not looking, especially with their own babies.
Okay. Okay.
Real gross.
On that note,
Budgie regards.
can we change? Can we have
Budgie
another note?
regards.
I
Anyway.
have a hard out. I gotta go. I gotta go.
okay,
I gotta
go.
run. I got
Kai's,
stuff,
Kai's,
going
Kai's
on.
still awake. I'm
early.
single
Well,
momming,
I'll see you both
so-
in 2 weeks.
Yeah. 2 weeks. That's
Oh.
right. You're taking a week off.
Yes, although Kiki, I may see you in person if the snow allows it.
I know there's all sorts of snow right now, so I hope you make it through the mountain passes and have a great
Yes.
adventure. That's
I
not
will pack lots of
involving-
water and food every time we hit the road.
Take main roads. Don't go. I'm just gonna take this weird little. Google's telling me to do this side road. Oh, is it even paved? I don't know where we're gonna end up. Yeah, don't do that.
I will be taking freeways.
Yeah,
I gotta go.
Well,
I
keep
gotta
in
go.
touch. I'll
Say-
see you both in 2 weeks.
2 weeks. Okay.
Good
so
night,
just-
Blair.
Blair. Say good morning, Justin.
Good morning, Justin. Good night.
Good
Kiki.
night, Kiki.
Good night, everyone. Thank you for joining us for another episode of TWIS. We will be back here again next week, minus Blair.
Yeah.
But it's going to be awesome. We hope that it's plus all of you. Stay safe, stay healthy, stay happy, stay curious. Ciao bellos.